Now I'm going to be supplying you with this flow chart as well, but I won't be supplying any other charts other than that one. Okay, um, give you a structure, you have to name it. So we're using our standard process. First thing is identify the longest carbon backbone that contains the functional group. In this case, we've got to start up here because it's got to include the OH. Okay, so we have two branches, an ethyl branch on
Professor, what practice test is this on the files? Because I printed two out and it's not the one you're doing.
um
Oh, it's the review.
yeah, let's make sure it's see this review is different. Did you print this out?
No, I didn't print that review out.
Okay. Well,
I
this one,
think the ones I did was the Chem 131 test, and those were it. It
the
was
ones up here.
yeah. Yes.
Okay, I don't remember which one of these is the one I'm going over right now. I'll post this when I find it after we finish, so you'll know.
Okay, I'll just take notes then. I wanted to kind of follow along, but I'll just take notes and then revisit it.
Well, I tell you what, why don't let's do this differently. Um, okay, so what I'm going to do now is load one of them. Which one did you
I printed the one that you uploaded yesterday. It says on August 5th. That's the one I printed.
Okay, let me, sorry about this, you guys. Let me, yeah, guess what? They all say August 5th. Was it this one here, the one that says yesterday?
Yes, the one fourth from the starting counting from the bottom up, the fourth one up.
Okay, all right. Fourth one up. Okay, so let's go to here. Okay, is that it?
Yes.
Okay.
Thank you.
Okay, so we have a structure, we have to name these guys. Okay, so this is benzene with two methyl groups, and there are, okay, the backbone is going to be the benzene. So we have two methyl groups. So it's going to be, okay. All right, this guy, need to find the longest carbon backbone that includes the alcohol functional group. So we've got two branches, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's no name. So alcohol, carbon backbone, and we have a methyl and a T-butyl branch.
Wait, I'm sorry. Can you confirm how is it nine? Because I actually, the lines are kind of confusing me. and versus where there isn't lines.
Did I count wrong on the yellow backbone? No, there's 9. What part confused you?
Okay, so when you're counting the backbone, you're counting the hold on. 1, 2, 3, 4, 5, 6, 7. Okay, never mind. I found my mistake.
Okay, cool. Okay, so we have, now I haven't stressed butyl branches very much. In past years, I stressed them more than I have to this semester. Anyway, this is a T-butyl branch. And it's on 1, 2, 3, 4, 5. And this is on 3. Okay, so ignore the T. So that ends up being a B-butyl. B comes before M. So T, 5-T-butyl, 3-methyl, no, not, no. No, nah, no. I don't know why I can't say that very well. Okay, this guy here, okay, is a um, double alkene, 2 double bonds, 2 double bonds, and we're looking at let's see here. 1, 2, 3, 4, 5, 6. So it's a hexadiene that is also an alcohol. Okay, so we're looking at 1 for the alcohol, 2 for this double bond, and 5 for that double bond. And then we have a methyl branch on carbon number 1. Now, on your test, you're not going to have a combination like this. It'll either be an alcohol or a double alkene, but not a combination. We didn't really go over examples of that during lecture. Okay, here we've got a oops, a cyclohexene, and the numbering is either going to go this way or this way. If we start with the 1 here, that'll give us smaller branch numbers. If we go the other way, the branches, the 2 methyl branches ends up being pretty large numbers. So we're going to start with 1 over there. Okay, so that's 1, and then 2, 3, dimethyl cyclohexene. Let's this paper. Okay. Now we have two phenol branches on this thing. So we have and when benzene is a branch, it's a phenol branch. So it's 1,2-diphenyl ethene. And it is a cis as well. Okay, so we have
Actually, about that, isn't the phenol, wouldn't a phenol have an OH instead of the CH it's connected to?
an OH.
Like for it to be instead of like a benzene ring, a phenol, isn't that OH? Uh, I don't know if I'm making sense.
OHs are alcohols. Is that
Right. I'm saying, wouldn't these be benzene rings, or what makes them a phenol group?
the benzene rings?
Okay, so because
Weird,
they're
the
branches
weird,
off it, go ahead.
the weird thing about benzene is when it's a branch, it's called phenol. When
Hmm,
it's the main thing, it's called benzene.
gotcha.
Remember how we did up above
Right.
yeah, it's weird that way. I don't know why it's different like that, but it's just the way it is.
Okay. Thank you for the explanation.
Okay, all right, heptene. Heptene is 7 carbons long. And on carbon number 3, we have the double bond. Now I drew this as a trans and also draw it as a cis, which would look like this. Let's finish this out here. Okay, so let's do it as a cis now. That would be it drawn as cis. Either one would be correct because I didn't specify. And then we have the phenol here and the bromo there. And so our air backbone.
Um,
Okay,
can
yeah,
you go over how you decided to make the cis one look like that? Like how it's like flat right there where the double bond is?
right. You've got to have um, these two methyl groups are on the same side of the double bond. I mean, not methyl groups, but carbon attachments
Oh,
right here.
I see.
And then over here, see they're on opposite sides. Does that make more sense?
Yes, thank you.
Okay. Okay, so cyclopentanol, 5-sided, You can draw five-sided cyclic structures like that. Looks like a house, or the way the book does it, like this. Either way, I think I always draw it like a house because it's easier to draw for me. But you can draw it either way. And we need to have some alcohol. So that's going to be carbon number 1. And then carbon number 2 and 3 are going to have methyl groups. Okay, so we have a cyclohexane. And 1, 2, 3 methyl branches. A hexanol. On carbon number 2. And then we have 3 and 4 methyl branches. Okay, so hydrogen bonding requires an OH group, or a NH group, or an FH group. And since these are alcohols, and that's an alcohol, that's why it undergoes hydrogen bonding. Now, on one of the practice tests, I had this here. It's an ether. It is a dimethyl ether. Why does dimethyl ether not undergo hydrogen bonding? Because it doesn't have an FHOH or NH. It only has a OC. What is wrong with the following name? All right, if you draw this out, okay, so let's draw it out and then look at it. Okay, that's butane. And if we go 1, 2, 3 with an ethyl branch, that's what the structure looks like. Okay, now, which is wrong because this is the longest carbon backbone, not what we started with. Okay. Wonder what happened here. This looks like 1, 2, 3, 4. Okay, so that's butanol. Okay, so butanol, let's do this one here first. Okay, so if we look at the flow chart, see where it's located, where's the flow chart? Now, if we look at this guy here, now this was we had an alcohol, butanol, under acidic conditions and at 140, that means it forms the ether. So with ethers, you connect the two alcohols together where the OHs are attached. So there's one OH. There's the other OH. So this is the area here that's going to be attached. So these two are 2-methylcyclopentanol, and the ether is it's going to be di. So it's going to be di-2-methylcyclopentane ether. So whenever you're forming ethers, you just attach the two OHs together. Okay, so this is a primary alcohol. Undergoing oxidation. Primary alcohols, if we look on our flow chart, here we have an alcohol. We can oxidize it. Primary, it goes to first to the aldehyde, then on to the acid. Excuse me. So the OH group is turned into an aldehyde. And then it continues to be oxidized to the acid. all you need to say here is aldehyde acid. And this would be on butanol. This thing got, some of these got chopped off. Okay, so this one, this is an alcohol, secondary alcohol. If it's being oxidized, sometimes. Okay, so secondary alcohols go to ketones. And this is a 1, 2, 3, 4, 5. So that's 2 pentanol. And the OH becomes a ketone.
Professor, how would you know it was secondary? I don't know if I missed that.
Because there's only one H here on that carbon. Primary, there are 2 H's. And then tertiary, there are no H's. Now, if this was, for example, instead of H here, if it was a methyl group, that would mean it's a tertiary alcohol, and they cannot be oxidized. So no reaction. Okay? So primary alcohols can be oxidized, secondary alcohols can be oxidized, tertiary alcohols cannot be oxidized. Primary alcohols go through 2 stages. They go first go to an aldehyde and a ketone, actually an acid. Secondary alcohols go once to a ketone and can't go any further because there's no, and what happens is it can be oxidized however many hydrogens we have. So we have 2 hydrogens here, so it can be oxidized twice. We have 1 hydrogen here, can only be oxidized once. Is that better?
Thank you, yes.
Okay, so we have propane. And oxygen and heat, that means we end up burning it in combustion. So that's CO2 and water. Sometimes instead of heat, I'll say spark. like on the flow chart. But oxygen definitely needs to be there. Oxygen can also be here or there, either place. Okay, so we have butene, one butene, and we have an acidic water. That means the water is going to add across the double bond here. And here. And it's going to be a mix. And Markovnikov, like this bigger. And symmetry for each one. Okay, so we have 3 hydrogens here, 3 hydrogens here, 2 hydrogens here, 3 hydrogens here. So that means Markovnikov wins out here. And they're both lopsided, but this one is less lopsided, the one on the left. So that one's going to be the more stable one. On the flow chart also, you'll notice the I mentioned there's a mix. Because we are talking about alkene going to an alcohol with water and acid. And then it says expect a mix. So that's the mix. Okay, so we have one butene again, and this time we're adding a homogeneic additive. That means we're not going to get a mix. Oh, we need to name this too. This is going to be 1-butanol. This is going to be dichloroputane. Okay, 1-hexene. This is going to be like this. And we're adding hydrogen gas, H2, across the double bond, and there'd be no mix. So we're just going to change the double bond into single bond, making hexane. Okay. So we've got the same reaction down here again. We have acidic environment with water being thrown across a double bond. So that means we're going to get a mix. Okay, so we can get OH is going to be here, OH is going to be there. Now these are secondary alcohols. That means they have an H here and H here. Needs to mean they're secondary. So when they're oxidized, secondary alcohols oxidize to the ketone. Okay, so we have an alkene adding a water across this double bond. We had a mix where the OH goes to each side of the double bond and then forms secondary alcohol. So these are secondary alcohols. Secondary alcohols, when further oxidized to ketones. So these are ketones. Now in this mix, it's kind of hard to tell which is more stable. I mean, I would guess the bottom one is more stable, but it's kind of hard. They're both asymmetrical. They're not all that symmetrical, but the one on the bottom is a little more symmetrical than the top one. So I'm leaning towards that one from the symmetry standpoint. A Kalmnikov that's going to be the same on both. So the only thing you can go by is symmetry. Okay. Let's redraw these here. Okay, so this is going to be tertiary. This is going to be primary.
Did you miss a CH3 on your, oh, there we go, on your second drawing?
Yeah, just left off the hydrogen. Okay. All right. This is kind of a pain. On your test, I'm not going to have a cyclo no name. A nine-sided cyclic is really hard to draw. So I would have something like probably cyclohexane. Okay, so let's draw it. Okay, so we have one isopropyl, two ethyl. So how many carbons does this guy have? Well, 6 on the ring, 7, 8, 9, 10, 11. Now the no name would have 9 plus 2 plus 3. So that'd be 3 more. 6 versus 9 on the cycling. And I didn't talk about hybridization in this semester. That's out of the scope of the class. And I don't believe we touched upon this either. Did I go over ortho, para, meta with you guys?
No, I don't
No.
think so.
Yeah. Basically, it's another way to and this won't be on the test, but it's another way to name benzene compounds. So if they are together, that's called ortho. If they're opposite, that's called para. And then if they're one apart, that's called meta. So this would be dimethyl ortho dimethyl benzene. This was propyl, would have a propyl group there. And this would be para dimethyl benzene, and this would be meta. That's all. You could also name it with numbers. If I was, this would be a 1, 2. This would be a 1, 4. This would be a 1, 3. Dimethyl benzene. Okay, here I wanted you to talk about our Markovnikov's rule. And this is a reaction here. We have one hexene. More water, probably like a little acid in there too. Okay, what happens is we get an OH here and an OH there. And then we count the terminal hydrogens. So this would be 3 H's here, 3 H's here, 2 H's here, 3 H's here. And this would be 6 versus 5 H's total. So that one would be more stable. So this is going to be 2 hexanol, 1 hexanol. Normally, when the hydrogen hydroxyl group is on the end, it's never the most stable because it's so lopsided. That hydrogen oxygen combination has got hydrogen bonding, so it's extremely polar. That's what I was looking for here. Okay, I guess that's the end of it. Now, if you look at the other practice tests, they're going to be similar lengthwise to this. So what is this? 5 pages. Now, organic tests tend to be longer because these structures take up a lot of room. So we've got intermolecular forces that I didn't talk about on this test. I wonder. Well, your test is going to have intermolecular forces on it. So I'll give you some compounds and ask you which has the higher boiling point, melting point, and surface tension. So you've asked questions along the way. Do you have any other things you want to talk about? You'll have 2 hours for this test.
Can you show one more example for the last problem you just did?
This one here.
Yeah, the very last one.
Okay, so that is this guy here. We have an alkene and an alcohol being added to the double bond. Water and acid are the conditions. Now, expect mix. Okay, so we got 1, 2, 3, 4, 5, 6. So we have 3 hexene, 2 methyl. Okay, so if you think of water that like this. So this is where the OH forming an alcohol comes from, is this part here. So we still need 6 carbon backbone. And the OH is going to form here and here. Now the next question is, which is more stable? Okay, the top one is more lopsided than the bottom one, so symmetry-wise, bottom one is better. Now Markovnikov is the same. We've got 3, 3, 3, and 3, 3, 3. So Markovnikov is 9 and 9, so it doesn't say anything. You can only go by symmetry again. Does that help?
Yes, thank you. I was just kind of wondering if the symmetry would be favored if they were both like on the same side. That's the one that's more symmetry, right? That has more.
Well, the bottom one's more spread out. Um, the this problem, if you circled the symmetry wins out on this problem, but if you circle the other one, I would maybe take off 1 point, maybe, or just make a comment. Because it's not all that obvious on this one. So yeah, just on the symmetry, eyeball it. Is it balanced or is it lopsided? If it's lopsided, I call it asymmetrical. If it's balanced, you'd say symmetrical. Now, whether it's perfectly balanced, no, it's not. So in your mixture, you'd get more of the one on the bottom than on the top. You know, like a 60-40 split or 70-30, something like that. Okay, and then we're not going to do this since I didn't cover it. Now, the only problem looking at old tests is sometimes I covered stuff that wasn't covered this semester. That's the only thing. So just be on the lookout for stuff like that. Now, schedule for next week is going to be I'm gonna start, I'll be available for questions at 1 o'clock on a Zoom, not noon. Because typically, hardly anyone gets on. So I will be available though. I want to make sure you understand that. And then I will be on campus on Monday as well for anyone who wants to take the test. And then Wednesday will be probably most of you. And then Wednesday also at 1 o'clock, I'll be available for questions as well.
And
But the
Professor,
test is at, oh, I'm sorry, but the test is at 3, correct? Wednesday.
Yes, yes.
and where do we find the Unit 1 reactions paper? That little graph.
This guy on the right here,
Uh-huh.
this here.
Yeah.
If you pull up Unit 1 dry labs,
Mm-hmm.
it's page 1. It's
All
the
right,
first
got you.
page.
Okay, thank you.
Sure. I'm also going to have this on the test too, like as I said earlier. Don't forget, next week is our first dry lab. Make sure you've got your pre-lab done. It's on alcohols.
You mean wet lab, Professor?
Yeah. Wet lab. I don't know what I said. What did I say?
You said dry lab,
Oh, yes. Wet
but it's
lab.
showing, Professor, it's showing on our schedule that our first wet lab is on the week of 9/22 and 9/24. So one more, not next week, but the following week.
Does it show next week is a dry lab?
Well, next week is our exam, which we're taking during the lab time, so the wet lab would have to be the following week, correct?
Yeah, yeah.
And it says dry lab 3 for next week.
Yes, but that's all the dry labs I included into that one PDF that says Unit 1 dry labs.
Yes.
Now that's a really good thing to study for the test because it's got reactions in it, it's got naming, drawing structures, etc. Now I can be at school earlier than 3. So if you would like, well, I just have to brush my teeth and take the dogs out, and I'm going to leave. So I'll probably leave at, let's say 1:30. So I should be at school by 2.
On the test, are we allowed to have like a note card?
No, you're going to have, starting with test 2, you can have a note card. Carbohydrates structures are challenging, and I usually let people have a note card for that test.
Professor, and we will be having the Lewis structure portion of the test, or no?
No, I just dry lab 0 I put together just as a review because as you can see we had so many structures and we're going to have zillions of structures from now to the end of the semester. That's the only reason I did that dry lab 0. So no, I'm not going to. If you can do the structures that we've been doing, you are doing Lewis structures. You're just leaving off parts. You're leaving off the H's and the C's, but you're doing Lewis structures. Like in this test, we did about 30 of them. So I'm not going to have a Lewis structure separate question per se. Does that make sense?
Yes, thank you.
And then for the dry labs, are you still going to be posting an answer key for us to double check our answers?
If you go to Canvas files, somewhere in here, I had a key to those because someone was using it in Lab Monday. Is that, are those two guys that were sitting sort of on the side in Lab on Monday? Are you on the line? Okay, they're the ones that had all the keys. I can post them. I will put them in here. And I'll make a new folder too. I'll say there they are here. It says Unit 1 Dry Lab Answers ANS. Okay.
Okay, I think I saw that one, but it doesn't show like every or all the pages that you had in our dry labs, like the ones that cover alcohols. I don't think I saw the answer key for that one.
Yeah, the Unit 1 Dry Lab answer key doesn't pop up on your phone on Canvas.
Well, it's zipped. Tell you what, I'll just create a new one. So I'm going to take this one off. And I'll make myself a note. So I will post that when I get home tonight.
Okay, and then also, as I was doing the dry labs that are due next week, I think you have a duplicate page of it says it's titled Organic Worksheet 6, but I think there's two pages that are the same.
Oh, we'll just do one of them.
Okay.
Okay. So I made myself a note and I'll put that together tonight.
Okay, thank you.
Sure. Any other questions, you guys? See. I see where you Nicholas, I see where you yes, come at 3 on Monday. Yeah, on the phenol versus phenol. Yeah, they're pretty similar sounding. Is right. Um, spelling they aren't similar at all. It's just the weirdness. When you have a benzene as a branch, it's called phenol rather than uh, we're not doing regarding next week's dry lab. That's embedded already. That's like the last 2 pages of your packet, the Unit 1 dry labs. So no do dry labs next week. You can do the sunscreen one ahead of time if you want. That's fine. You should have enough. I'm trying to think. We'll look at it and see if you have enough information to do it. I think you should. It's a little iffy though. You might want to just wait a little while longer. Okay, anything else? All right, well, I'm going to end this. And for those who show up in lab today, I will see you then. All right, take care, you guys.
Take care. See you in lab.